all to Physics Unveil. My name is Franklyn, and today we're doing a special topic on the second order differential equation. Before you learn the second order differential equation, you must have been taught about the first order differential equation and their solutions. So in today's video, we're talking about the second order differential equation, and the thing we're talking under it will be the homogeneous equation, alright, under the second order equation. And then we now go into the solutions for finding the homogeneous second order equation. Now, for a second order equation, the form is in this way: a the square y the x squared plus b the y the x plus c equals to f of x. Alright? Sorry. cy is equals to what? F of x, where a, b, and c are called the constant coefficients. Alright? So this is how the second order homogeneous equation look like, or just a second order differential equation look like in this form, because we have this term, alright, the square y the x squared. So therefore it is a second order differential equation, alright? And then this f of x is a function of x, obviously. Now, going into the homogeneous differential equation, or the linear homogeneous differential equation, it is known that f of x, if f of x is equal to 0, we'll be having a the square y the x squared plus b the y the x plus cy equals 0, because f of x now is equals to 0. Now this is what we know as the linear homogeneous second order differential equation. Alright, so this is what we need to know about it. Right, so under the second order differential equation, there's something we call the auxiliary equation, and the auxiliary equation is gotten from a quadratic equation. Now, where is this quadratic equation gotten from? For example, now, when you're being given, especially a homogeneous second order differential equation, right? The square y the x squared is m squared, right? So m squared, please jot this down, very important. M squared is the square y the x squared, then m is the y the x, and then your 1 is just y. So if I turn this into a quadratic equation, we have this something like a, then this is what? M squared plus bm plus c times 1 is just c equals 0. This is a quadratic equation, and we call this quadratic equation the auxiliary equation of this second order, alright, homogeneous equation. And the general solution for a second order homogeneous equation is y equals to a exponential n1x plus b exponential m2x, where a and b are just arbitrary constants. Your m1 and m2 will be gotten from the quadratic equation that you solve. Obviously, m will have two roots, alright, which we call m1 and m2. You now fix those roots into this equation. So this is the general solution for a second order homogeneous equation. So now let's move forward to other solutions for the homogeneous second order differential equation. So now we have the solutions to homogeneous second order differential equation, right? And the first one is real and different roots. Now, from our auxiliary equation, which is the quadratic equation, am squared plus bm plus c equals to 0. Now, what this case is called a case 1, alright? The first case, real and different roots. Now, when we have an auxiliary equation and then we solve for the value of m, which will give us 2 roots, right? Because it's a quadratic equation, it gives us 2 roots. Now, those roots number 1 should be real. Real means all real numbers, right? From negative to positive, alright? Infinity. So, the general solution for a homogeneous second order differential equation when the roots are real and different. Different in the sense that we can have the first m as, let's say, -2 and second m as, let's say, 3, right? These are 2 real numbers, but they are different, alright? The general solution to that is y is equal to what? A exponential L1 x plus what? B exponential L2x, alright? So let's assume that you solve a particular auxiliary equation and then you have your m1 as -2 and your m2 as 3. The answer, the general solution to that homogeneous second order differential equation is y is equals to a exponential. Your m1 is -2 times x, which is -2x, plus b exponential. Your m2 will be what? 3x, and that will be the answer. This is when the roots are real and different. Now let's go into the case 2. For case 2, which is the real and equal root, after solving your auxiliary equation, which is am squared plus bm plus c equals to 0, and then we have 2 equal roots. Let's say we have your first m as, let's take as 4, and your second m take as 4. 4 and 4, they are real and they are equal. The general solution for the homogeneous second order differential equation when the roots of the auxiliary equation are equal is y is equals to exponential m1x bracket a plus bx. This is the answer for when you have real and equal roots. Alright? So let's use this for example now. Let's assume we solve a particular auxiliary equation and then we get its roots at 4 and 4, or 4 twice. The answer or general solution to that particular second order equation I gave you will be y is equals to exponential m1 is just, since m1 and m2 are all the same thing, just pick one, which is 4, right? 4x open bracket a plus bx. That will be the general solution to that auxiliary equation, and this is how you have it, right? So now let's go into the case 3 and see what will give us. So the case 3, or the case 3, which is about complex roots. For complex roots, now for the auxiliary equation, am squared plus bm plus c equals to 0, and then you try to solve for m, probably using the general quadratic equation, which is also known as the almighty equation, and the value of the root is complex, which is like alpha plus plus or minus I beta, alright? This is a complex root, right? The general solution for a homogeneous second order differential equation when the root is complex is y is equals to exponential alpha x open brackets a plus beta x plus b sine beta x. Of course, you know from a complex number that alpha is the real part and beta is the imaginary part because this complex number are here. So this is the general solution for a homogeneous second order differential equation when the root is complex. right? Second order differential homogeneous equation where the form is like this: the square y, the x squared plus n square y equals 0. Now for this kind of equation, alright, the general solution to this is y is equals to a cos nx plus b sine nx. Alright, so for example, imagine you have something like the square y, the x squared plus, let's say, 16, right? Plus 16y is equals to 0. Right? So if you do that, what we have? You know that n squared is equals to 16, right? So therefore, n is equals to 4. So therefore, the general solution to this is y is equals to a cos 4x plus b sine 4x, and that is the answer or the general solution to this kind of second order differential equation. So for this type, we don't have the first power, right? We don't have the first order, we only have the second order and the last thing y. Alright, so this is the general solution for that kind of equation. So moving into the second part, which you have the second order, the square y, the x squared. Now there's a minus now, not a positive now, but negative. Negative n squared y. What is the general solution to this kind of second order differential equation? It's very simple. The general solution is y, this time around to give you a hyperbolic function. A cos nx plus b sine nx, hyperbolic function. Alright, so this is how to solve this kind of question. So let's use a formal example. Imagine you have the square y, the x squared minus 16y is equals to 0. Obviously, n squared is equals to 16, right? So n is equals to 4. Because there's a negative sign here, the general solution to this second order differential equation is y is equals to a cos 4x plus b sine 4x. And that is the answer, which is the general solution to this differential equation. Thank you for watching. Please make sure you like and subscribe and you share around to people, to your classmates and the rest. So I'll tell you bye for now.